This is a test 1 review for MSc 1105C. There are 35 questions. I'll go over. Um, Number 1, write a compound inequality for the graph shown below. Use x for your variable. So as you can see that the graph started at 5 and there is a closed circle and there is an open circle. So if you want to write down that, then x is greater or equal to 5 and less than 7. So do not include 7 and include 5. That's number 1. Number 2, we have given C and D. We want to find out the intersection of C and D and union of C and D. To understand this problem, let's plot C on the number line, which is 0, 1, 2, 3, less or equal to 3. So something less or equal to 3, including 3. And D means 0, 3, 4, 5, 6, 7, 8, somewhere here, less than 8. So by looking this, you can see that C intersection D, the common on C and D, it's something, the intersection is 3 and less. So that means it's, so we have to write down our answer using the integral notation. So it should be from negative infinity to positive 3 including 3. That is common on C and D both. And union would be from negative infinity to positive 8, not including positive 8. Union means everything from C and D. That's problem 2. Question 3. Graph the set on the number line, then write the set using integral notation. So we have to start from negative 6. Negative 6 is here, open circle. Positive 3 is here, open circle. And anything between negative 6 and positive 3. So this is the graph. And if we want to write down using the integral notation, it would be parenthesis negative 6 comma positive 3 parenthesis. Number 4, solve the inequality. So we can just divide both sides by negative 3, and after dividing both sides by negative 3, the sign will change, the reverse, and it will be greater than this, which gives us x is greater than 4. Number 5, solve the compound inequality. To solve this one, we have to isolate x. So that means, first of all, let me write down the problem here. It's number 5. Negative 13 is less or equal to 4x plus 3 is less or equal to 11. Subtract 3. So that gives us negative 16 is less or equal to positive 4x. Less or equal to 11 minus 3 is 8. And there is a 4, so we have to divide the inequality by 4. So it gives us negative 4 is less or equal to x less or equal to 2. So that's the solution, and we have to graph the solution on the number line. So as you can see that it's start from negative 4 including negative 4, and goes up to positive 2, including positive 2. So we can just start from negative 4 to positive 2. So that's the graph. Okay, that's problem 5. That's problem 5. So the next problem is problem 6. Once again, solve the compound inequality. So we're going to solve the left inequality and right inequality, and the final solution would be intersection of the solution for the left one and solution for the right one, because there is an and. Okay, so let's solve it. 3u plus 4 is greater than 2. So to solve this one, just subtract 4. So 3u, this 4 is gone, is greater than negative 6. And if we just divide both sides by 3, u is greater than negative 2. And second one is 4u minus 3 is greater or equal to 9. We need to solve this one as well. So 4u is greater or equal to 12. If we divide by 4, u is greater or equal to 3. So because we need to find out the solution, and there is an n between both of them, so that means we are trying to find the union of u is greater than negative 2 and u is greater or equal to negative 3. So it should be union, so that means it should be everything. So the union of these two things is everything, so that means here it's greater than negative 2, so that means everything to the right side, and u is greater than positive 3 means everything to the right side. So union of these two is uh, everything greater than negative 2. So the solution in the interval notation is starting from negative 2 to positive infinity. That's the final solution. That's the solution. Because for this inequality there is an and, so we need to find out the union of the first one and the second one. That's problem 6. For problem 7, factor 3g squared plus g minus 2, we can use the AC method. So here you can see there is a 3 for A and negative 2 for C. So 3 times negative 2 is negative 6. So we have to find out the factor of negative 6 such that some of those factors should be the middle coefficient, which is 1. So let's take 3 and negative 2 as it is. So 3 minus 2 is 1. So we can split this problem like 3z minus 2z minus 2. And now we can factor by using the grouping. So factor out 3z, it gives us z plus 1 from the first two. From the second last two, we can factor out 2, and that gives us z plus 1. And one more time, you can see that there is a z plus 1 and z plus 1 common factors, so we can factor out z plus 1, and left over would be 3z minus 2. So that's the factor for problem 7. For problem 8, we can do the same thing. We can multiply 9 and 25, which is 9 times 25 is it's 9 times 5 is 45. Let me just find out. It's a 225. It's a 225. So 9 times 25 is 225. And now we need to find out the factors of 225 such that the sum would be negative 30. So when we try to find out the factors of 225, and let's see how we can do that. It's a 15 times 15, or negative 15 times negative 15. So it's negative 15 times negative 15. So I'm using negative 15 times negative 15 because sum of negative 15 and negative 15 is negative 30. So we can split this middle term as negative 15x, negative 15x, positive 25. Now we can factor from this first two terms, which is the greatest common factor is 3x, and the leftover would be x minus 5. From last two term we can factor out 5, and leftover would be 3x minus 5, and here is the common factor. Sorry, I missed the 3x here. 3x minus 5, so it's a 3x minus 5 times 3x minus 5. So it's a factor for 9x squared minus 30x plus 25. You can also write down this as 3x minus 5 squared. That's problem 8. Now let's do problem 9. As you can see, I'm using the AC method, again and again. There is a 1 coefficient in front of y square, and there is a negative 20. So if I multiply negative 20 and 1, it gives me negative 20. Now I need to find out the factor of negative 20 such that the sum of those factors would be positive 8, and I can use 10 times negative 2. 10 plus negative 2 is positive 8, so I can use y square plus 10y minus 2y minus 20, and I can use a grouping method, meaning I can factor out from these first two terms and last two terms. From the first two terms, the common factor is y, and after I factor out that y, the leftover will be y plus 10. From last two terms, the common factor is 2, and if I factor out that 2, it gives me y plus 10. So there is y plus 10 common, so I can factor out y plus 10, and I can write down the leftover y from here, negative sign from here, and 2 from here. So the final factor is y plus 10 times y minus 2. So that's the final factor for the problem 9. Let's go to the problem 10. One more time, we can do the same thing. 3 times 30 is 90. Now we need to find out the factors of 90 such that the sum of those factors would be 23. So let's try to find that. So 90, let me try to find out the factor for that. So it's we need 23. So let's find out the factor. 2 times 45, 3 times 15, 2 times 45, 3 times 15. Okay, so factors of 90, we can find 18 times 5 is 90, and then 18 plus 5 is 23. So we can split this as 3x squared plus 18x plus 5x plus 30, and we can use the same trick here. We can factor out the 3x, which gives us x plus 6, and we can factor out 5 from last two term, which gives us x plus 6 again. So finally the factors are 3x plus 5 and x plus 6. These are the two factors. Okay, so now let's go back here for problem 11. Problem 11. Problem 11 is again, it's a factor completely. Negative 5 times negative 10 is positive 50, and you can find the factor of positive 50, which is 25 times 2, or maybe negative 25 times negative 2, and then sum of this negative 25 and negative 2 is negative 27. So we can split this negative 27 as a negative 25. um, V, I think it's a V, or gamma, the symbol. Let's say this is V square 25 negative 2V negative 10. Now we can factor out from the first two term, which is negative 5V, and it gives us V plus 5. From last two term, it's a common factor is 2, so it gives us V plus 5 again. And if I factor out V plus 5, it gives me negative 5V negative 2. So that's the final factors for problem 11. Problem 12, I can write down the first term as a 2 square and the second term as a 3u square. I can use the difference of square formula, which is 2 minus 3u times 2 plus 3u. That's the final answer or the factor for this problem. Let's go to problem 13. Once again, factor completely. So try to factor the greatest common factor here. We can see that 75 can be written as 3 times 25. 48 can be written as 3 times 16. So 3x. I can factor out 3x, which gives me 25 minus 16x squared. And this is not done, because I can still factor this thing. I can express, let's say 25 can be written as 5 squared, and 16x squared can be written as 4x squared. So it's again the difference of square, so it gives me 5 minus 4x times 5 plus 4x. So that's the complete factor. I cannot go further than that. Let's go to problem 14. Once again, I can use the same trick here, or I can use, it looks like a complete square, complete square trinomial. I can use the AC method. I can find out the factors of 64, which is 8 times 8, or maybe negative 8 times negative 8, and that gives me the sum negative 16. So eventually it will be y minus 8 squared. So y minus 8 and y minus 8. Okay, because 64 is negative 8 times negative 8, and negative 8 plus negative 8 is negative 16. So I can split this negative 16 as negative 8 and negative 8. So this is the final answer. Problem 15 can be written as y squared minus 6 squared, which is once again is a difference of square. So I can write y minus 6 and y plus 6 are the two factors for this problem. Problem 13, 16, 15. Let's go to problem 16. We have to solve the quadratic equation. On the left side it's quadratic, and then on the right side there is a 0. So we can just find the factor on the left side, which is 3y. Y minus 6 is equal to 0. And now I can use the zero product property. That means either this equals 0, which is either 3y equals 0, or y minus 6 equals 0. If I solve the first one, it gives me y equals 0. And if I solve the second one by adding 6 both sides, it gives me y equals 6. So these are the two possible solutions for problem 16. either y equals 0 or y equals 6. Okay, let's solve problem 17. This is also quadratic equation, but to solve the quadratic equation we need 0 on the right side, so we can just subtract v from both sides. By doing that, our equation would be 2v squared minus v minus 6 equals 0. You can solve this by using the factoring of this quadratic, this trinomial. And if I use the AC method, I can find the factor. Negative 6 times 2 is negative 12, and negative 4 times 3 is also negative 12. But if I add negative 4 and positive 3, it gives me negative 1, which is the middle term. So I can write down this problem as 2v squared minus 4v plus 3v minus 6 equals 0. And I can factor out by using first two term and then last two term. So the factor from the first two term is 2v, which gives me v minus 4. The common factor, the GCF from last two terms is 3, and after I factor out that 3, it gives me v minus 2 once again. And now I can see that here should be 2, because after I factor out 2v, the leftover will be 2. So now v minus 2 is one of the factor, 2v plus 3 is another factor. I can use the zero product property, so it tells me either v minus 2 is 0 or 2v plus 3 is 0. Now I can solve for the v, and for that, if I add 2 on this equation, it gives me v equal to 2. And to solve this one, I have to subtract 3 and divide both sides by 2, so that gives me v equal negative 3 over 2. So these are the two possible solutions for problem 17: v equal 2 or v equal negative 3 over 2. These are the two possible solutions. Okay, and now let's go to problem 18. U squared minus 9u plus 18. So 18 times 1 is 18. So to find out the factor on the left side, the factor will be 6 times 3, negative 6 times negative 3. So x minus 6, x minus 3 are the two factors, because negative 6 times negative 3 is positive 18. Negative 6x, negative 3x is, so instead of x here you have u. Sorry about that. So we have these factors. Now I can use the zero product property, which tells me either first factor is 0 or the second factor is 0. Now if I solve for u, it gives me two options, either u equals 6 or u equals 3. So these are the two solutions for problem 18. Now for problem 19, before we need to change this problem into the problem like problem 18, and for that we have to expand this x minus 3 square on the left side, on the right side. On the left side we have 2x squared minus 4x plus 6, and on the right side there's x minus 3 squared. So if I multiply x minus 3 and x minus 3, it will be x squared minus 6x plus 9. Now I need to bring everything on the left side, so I'm going to subtract x squared, add 6x, and subtract 9. So my problem would be, let me take it here. I'm going to subtract x squared. So 2x squared minus 4x plus 6. I have to subtract x squared, add 6x, and subtract 9. By doing that, on the right side I will have 0, and on the left side I will have x squared plus 2x minus 3 equals 0. And now I can find the factor of this, which is x minus 3 and x plus 1. So if you multiply negative 3 and positive 1, it gives me negative 3. Negative 3 plus 1. Okay, so I need positive 3 and negative 1, because positive 3 and minus 1 gives me positive 2. Positive 3 times negative 1 gives me negative 3. So now I can use the zero product property, and I can say, oh, either first factor is 0 or the second factor is 0. So that means either x is negative 3, that's the first solution, or x is positive 1, that's the second solution. Possible solution for problem 19. Okay, so when you write the solution here, it's negative 3 comma positive 1. These are the two solutions for problem 19. Let's go to problem 20. Find all excluded value for the expression. Remember, whenever we are using the rational expression, the excluded values restriction always comes from the denominator. So we have to make this denominator uh, 0 and solve for the variable that always gives us the restriction. So in this case, w equal negative 3 is our restriction, because if w is negative 3, then the denominator part would be 0, and 0 on the denominator is undefined. So um, so w equal negative 3 gives us the undefined value here. For 21, to simplify this rational expression, we have to find out the factor on the top, which is x minus 4, and factor on the bottom, which I can find by using the AC method one more time. So I need to find out the two factors of 16 such that the sum would be negative 8. So negative 4 times negative 4 would be 16, and sum of negative 4 and negative 4 is negative 8. That's why these are the factors. And because x minus 4 is the common factor on the top and bottom, after cancellation of the common factor, we get 1 over x minus 4 as the simplified form of problem 21. So we are going to simplify this to rational expression for problem 22. So on the top part, there is no GCF, so 4w plus 3 is the prime factor. On the bottom part, there is a 3w plus 4. So we don't see any common factor, so this is the most simplified form. But for the second part, as you can see, if I factor out negative, then it gives me 5. I can write down the top part as 5 minus 2w, and on the bottom part it's already 5 minus 2w. So by just rearranging the sign on the top part, I will get the same factor, and I can cancel the same factor, and the leftover will be negative 1. Okay, that's problem 22. Problem 23, one more time, we would like to simplify it. So just factor out the GCF from the top one, which is 3u. After that, it would be u minus 7. And factor out the GCF, greatest common factor, from the bottom part, which is 3u, one more time. And after that, I will get u minus 5. So this 3u, it's a common factor on the top and bottom. So after cancellation the common factor, the leftover would be u minus 7 on the top and u minus 5 on the bottom. That's the most simplified form. Now for 24, we already have some common factor here. On the top there is a 3u minus 4, and there is a 3u minus 4, so we can cancel out one of this, and leftover will be 3 here. Here u minus 6, 4 of them on the top and 5 of them on the bottom, so we can cancel the 4 of them. And now the leftover is 24 over 18, so we can find out the factor of 24, which is 2 times 2 times 2 times 3, and there is a 3u minus 4 cube, and factor of the 18, 2 times 3 times 3, and there is a u minus 6. So we can cancel out the common factor one more time. And by doing that, on the top part we get 2 times 2, which is 4, 3u minus 4 cube over 3u minus 6. So that's the most simplified form for problem question 24. Question 25, again we need to simplify, so let's find out the factors on the top, which is u minus 5. There is nothing we can do, but for the bottom part we can write down u square minus 25 as a u square minus 5 square, which gives us u minus 5 u plus 5. Since there is a common factor u minus 5 on the top and bottom, so we can cancel that, and on the top there will be 1, and on the bottom there will be u plus 5. So that will be our final simplified version. So for problem 26, we need to multiply the two rational expression. For that, we're going to find out the factors of each of them on the top and bottom. Here we can see on the top there is the common factor 6, so x plus 4. On the bottom there is a common factor would be 7, so it would be 8x plus 3 for the first expression. For the second expression, there is nothing we can do. There is nothing common between 8x and 3. But on the bottom part, there is a greatest common factor 2. So we can factor out 2, and it will give us x plus 4. Now after that, let's cancel the common factor x plus 4 and x plus 4 from top and bottom, and 8x plus 3 and 8x plus 3 from top and bottom. And there is also 6 on the top and 2 on the bottom, so we can cancel 2 times 3 is 6. So finally, after that cancellation, the leftover will be 3 over 7 only. That's the multiplication of these two rational expression. 27, we're doing again the same kind of thing, multiplication. So from the first rational expression, there is, on the numerator there is nothing we can do, but on the denominator we can factor out 4, which gives us x minus 3, and for x squared minus 2x minus 3, we can find out the factor here. The product of two numbers will be negative 3, and sums will be negative 2, so that will be negative 3 and positive 1. So by multiplying these two, we are going to get this one. So similarly, for x squared plus 5x plus 6, we have to split the 6 such that the sum of the factors will be positive 5, and that will be x plus 3 and x plus 2. So I'm going to use this factor here, which is x minus 3 times x plus 1 on the top, x plus 3 and x plus 2 on the bottom. Now I'm going to cancel the common factor from the top and bottom, and then I'm going to write down the leftover thing. So on the top there is x plus 1, and on the bottom there is a 4 times x plus 3. So that's the most simplified form of this multiplication. Let's go to problem 28. Once again, it's a multiplication of rational expression, so we need to find out the factors on the top and bottom. So for the first expression, there is a 9x squared minus 25, so we can write it down as a 9x squared minus 25 can be written as 3x squared minus 5 squared, which is actually 3x minus 5 and 3x plus 5. So these are the factors for 9x squared minus 25. So it's 3x minus 5, 3x plus 5. On the bottom we can use the AC method. So if we do that, negative 14 times 2 is negative 28. So we are looking for the So let's find out the factor of this. Negative 2x squared plus 3x minus 14. So negative 14 times positive 2 is negative 28. So I need the factor of negative 28 such that the sum of those factors should be positive 3. So 7 times negative 4 is negative 28, and 7 minus 4 is positive 3. So I can split this 3x as 7x minus 4x, and I can find the factors now. Here the common factor is 2x, just x, 2x plus 7, and from the last 2 it's 2, so it's a 2x plus 7. So the factor are 2x plus 7 times x minus 2. So these are the factors for 2x squared plus 3x minus 4, which is the denominator of the first expression. So I'm going to use that factors here, 2x plus 7 times x minus 2. These are the factors for the first rational expression. And from the second one, the common factor is 5, so x minus 2. And on the bottom one, there's nothing we can do. So after that, we can cancel the common factor from the top and bottom. And finally, the leftover will be our answer. So the leftover is 5 times 3x minus 5 over 2x plus 7. So that's the final answer for problem 28. Okay. For the problem 29, here we have to divide the rational expression. So we can change this problem from division to multiplication by flipping. So this is 18x plus 8 over 9x plus 54. We can change the sign from division to multiplication, but for that we have to flip the rational expression, the second rational expression. So it would be now 3x plus 18 over 9x plus 4. So now let's try to find out the factors of each of them if it's possible. So from the top one, we can see that the common factor is 2. So that gives us 9x plus 4. On the bottom one, the common factor is 9. And there is a x. For the second expression, the common factor is 3. That gives us x plus 6. And there is nothing common between 9x and 4. So now we can cancel the common factors. So 3 times 3 is 9. And then it will give us the leftover thing, which is 2 over 3. So that is the division of these two rational expressions. We can do the same thing here for the second for problem 30. We can factor out the first expression, and that will be x minus 3 and x plus 2, because negative 3 times positive 2 is negative 6, negative 3 plus 2 is negative 1. And now I'm going to change this division by multiplication, but for that I have to flip the second rational expression. After flipping, this x squared plus x minus 2 will come on the top. So I'm going to write down the factor for x squared plus x minus 2 as x plus 2 x minus 1, because positive 2 times negative 1 is negative 2. Positive 2 plus minus 1 is positive 1. And on the bottom one, there will be x plus 1. So now we're going to cancel the common factor from the top and bottom. And then leftover would be 3 times x minus 1 over x minus 3. So that's the most simplified form. Now, we are going to subtract a rational expression from another rational expression. If there is a common denominator, the subtraction is very easy. It's 19a minus 2 minus 9a, and we just have to write down one denominator 8a because of the common denominator. We can do that. So 19a minus 9a is 10a minus 2 over 8a. On the top we can factor out 2, so that gives us 5a minus 1. On the bottom it's already 8a, So we can cancel 2 times 4 is 8. So on the top it will be 5a minus 1. On the bottom it will be 4a. That's the most simplified form for problem 31. For the problem 32, to subtract a rational expression from another rational expression, we should have same common denominator, but there is a two different denominator, x and x plus 3. So we are going to find out the LCD, that is least common denominator, for this from these two denominator, and that is actually all the common factor times uncommon factor. Here we don't see any common factor, so the least common denominator will be x times x plus 3. So to make the least common denominator for the first one, we have to multiply the first rational expression by x plus 3 on the top, and then on the bottom it's basically we're just multiplying by 1, and we can always do that. And for the second one, to make the same denominator, we have to multiply the top by x and bottom by x as well. So now you can see that we have the same common denominator. So instead of writing two denominator, we can just write x times x plus 3, and on the on the numerator there is a 7 times x plus 3, so we can just distribute the 7 here, so that gives us 7x plus 21 minus 6x. So 7x minus 6x is x plus 21 over x times x plus 3. So there is nothing common factor on the top and bottom, so this is the most simplified subtraction of this problem. Let's go to problem 33. Before finding the LCD, we can just simplify a little bit. For the first expression, we can find the common factor 4, so we can write x minus 3 plus 3 over x minus 3. As you can see that the LCD for this problem is the common factor, which is x minus 3, and uncommon factor 4. So the LCD is 4 times x minus 3. For the first rational expression, there is already 4 times x minus 3. For the second one, there is no 4, so we can just multiply the top and bottom by 4. Now you can see that there is the same common denominator, so instead of writing 2 denominator, we can just write 4 times x minus 3, and on the top there is a 13 times 3 times 4 is 12. So finally it is 25 over 4 times x minus 3. So that's the addition of two rational expression. um, let's go to problem 34. We have to subtract, and one more time there is no common denominator, so we can find out the LCD. And in this case, the LCD would be everything, 7x minus 9 times 8x. So to make the same common denominator for the first one, we have to multiply by 8x. By doing that, we're going to get 7x minus 9 times 8x on the denominator for the first expression. And for the second expression, we have to multiply by 7x minus 9 on the top and bottom. By doing that, we're going to get the same denominator, as you can see here, 8x times 7x minus 9. Now we just have to copy whatever we have on the top part, which is 8x times 8x is 8x squared. X plus 3 times 7x minus 9, we can just distribute them like this. So it will give us 7x squared minus 9x plus 21x minus 27. So we can simplify more on the top part, which is 8x squared minus 7x squared. If we combine the like terms, negative 9 plus 21 gives us positive 12, but because of this negative sign, it will be negative 12x. There is a negative 27, it becomes positive 27 because of this negative sign when we open the parentheses. So on the bottom there is 8x times 7x minus 9, and on the top we can go further. 8x squared minus 7x squared is x squared minus 12x plus 27. and on the bottom part it's 8x times 7x minus 9. We are still not done because on the top part you can see that there is a trinomial, so we might uh, we can also find the factors of the trinomial on the top. So 27, the factor of 27 is negative 9 and negative 3. So negative 9 plus negative 3 is negative 12. So the factor on the top is x minus 9 and x minus 3. But there is nothing common factor on the top and bottom, so we just have to leave it as it is. Okay, simplify your answer as much as possible. That's what we try to do here. Finally, the last problem 35, we can make the same denominator by finding the factor for the second rational expression. On the top part it's 2 times x minus 2, and on the bottom part there is a 5 GCF. So after I factor out this 5, it will give me x plus 3. So to make the same denominator, the LCD is 5 times x plus 3. So I can make the same denominator by multiplying the first rational expression by 5 on the top and bottom. After that, 5 times x plus 3 is the least common denominator for both of them. So on the top there is a 5x plus 1 minus 2 times x minus 2. Now we can just simplify it on the top, which is 5x plus 5 minus 2x plus 4 over 5 times x plus 3. Now we can simplify more on the top. We can combine the like terms. 5x minus 2x is 3x, and 5 plus 4 is 9. So 5 times x plus 3. Still we're not done here because we have the greatest common factor of 3 on the top. That gives us 3 times x plus 3, and on the bottom there is already x plus 3, so we can cancel x plus 3 and x plus 3. So the leftover would be 3 over 5. So that is problem 35. If you have any questions, then please feel free to email me.